breaking the wall of space debris at scale. Niklas Wendel, Falling Walls Lab, Osnabrück.
Hello. Thank you for the invitation. I have the honor to present a project I worked for the last 5 years on. It is currently privately funded, and it is totally honorary. But it has a simple vision. Space is a natural resource. It does have tremendous potential, and it needs to be preserved. Consider this picture as an example. It's just beautiful, isn't it? So, space, it provides communication, navigation, Earth observation, supporting the fight against climate change. It is driving today's society, and the potential it has for future generations, it's just beyond our dreams, if we can preserve it. And that's what I want to talk about. Unfortunately, as beautiful as it is, this picture hides something. Since Sputnik, there have been thousands of satellites, now debris, which fill the orbits. If you made this visible, the picture unfortunately looks more like this. So, considering this, removal operations will be essential. Collision avoidance is currently underway, but we will have to find better ways. These numbers, thousands of them, dictate that we will need a highly scalable, cost-effective, and also universally applicable solution. And that's what I'm working on. So, if we prove scalability as one of the core drivers, we will need to take this wall down by covering several pillars. Those are, for example, passive deorbiting, optical remote sensing, and the ability to capture any debris object independent from its geometry. But, well, passive deorbiting, so to achieve true scalability, we will need to rethink removal itself. And each object has its orbital energy. If it loses it, it deorbits. So instead of burning fuel and creating mass dependencies, I personally think that the solution will look something more like this. A fabric like this is capable to interact with the atmosphere or the magnetic field, and therefore dissipate energy. By doing so, it is breaking the basic equation, which will always tie propulsive-based deorbiting. It's also shrinking the probe from the size of a car to the size of a larger luggage for our design. So, by these technologies, we try to achieve real scalability to match the size of our challenge. Currently, we have demonstrated feasibility. Prototypes are being built right now. We are aiming to develop and demonstrate the system under zero-G conditions within the next year. And I'm convinced that these technologies have the opportunity to remove the space debris hazard and start a new era of space sustainability. Thank you very much.